We're back here. We're going to be talking about Metars, kind of mopping up with some stuff here today. It's going to take a little work, but I think that with some study, you guys are going to get this just fine. I am feeling better today. Go me. And so hopefully I'll be able to speak a little bit better than I have the last couple sessions here. Pardon me whilst I sip. Yes, I love me some Timmy Tebow. Oh. Coffee today brought to us by the Cafe Du Monde in New Orleans here. Little Southern coffee with chicory. Tasty. We're just pushing up against Mardi Gras season down here, and so it is entertaining. Not just to mention the fact that traffic starts getting blocked off in places that you never knew there were places. So, excuse me. Yeah, so it's kind of a fun time down here. I'm going to miss it because I will be pushing back to Colorado tomorrow. So we're going to get into the Metars here, but first we're going to take a look at our weather here today. This is the latest surface analysis chart brought to you today by our friends at the AOPA. And when we look here, this is, as I mentioned, kind of the latest surface analysis. We can see here, off to the east, we can see areas here that we have these areas of high pressure here, little trough of low pressure here, several small little troughs of low pressure underneath these highs here also. Then we have some little low pressure areas here as well. We can see that just to the north of Colorado here into Wyoming, we see a couple of areas here where kind of these two converging lows are kind of here wrapped around a couple of little high pressure systems here. We can see that we're starting to get some weather, or predicting the weather certainly here in the northern part of Wyoming into southern Montana, western Montana. This next big piece right here that's in the upper part of the Pacific Northwest, pardon me, this is that piece that we think is going to kind of slide down here some direction, but the question is going to be is just how far south it's actually going to get into Colorado. Are we going to get a few flakes? Are we going to get anything at all? Remember that Vail, they're expecting somewhere in the next 16 days, or 15 days now, they're expecting somewhere between 3 and 6 feet of snow. And we are not getting that kind of forecast for Aspen. So it's going to be kind of different. And it's just kind of funny how just a few miles can make all the difference in where these systems roll. So I wanted to show you that. 12 hours, they're kind of looking for that low pressure to kind of move down into central Colorado. Here in the next 12 hours, you can start to see that this system moving in here from the Pacific Northwest. 24 hours, we can see the lows have slid down now into the panhandle of Texas and into Oklahoma. 36 hours, this is where they're looking for this weather maker to move into the Pacific Northwest, into Montana, Idaho, starting to move into Wyoming. Here it comes. And right now, they're looking for this chance here of this weather moving in to the high country here in west central, in west central Colorado. But we're just going to have to see, how that goes and sort of where it goes. Cold fronts again, moving weather here throughout the southeast. Kind of moving in down through here, through northern Louisiana, in here through Arkansas, Mississippi, Tennessee, the Virginias here, and into the Carolinas. So there will be another little weather maker here in the northeast part of the country. This is kind of again what they're predicting. As we look here, again, more at the prognostic piece here. This is going to be as kind of this next 12-hour range here, 24-hour range. It's interesting that we see a dry line here now already kind of starting to form. It's not even at the end, well, it is the end of January today, I guess. here. So we're starting to see this dry line. We're going to start seeing these dry lines moving into the spring, forming over here in this part here of the south, the desert southwest. These are going to be these dry lines that are going to be kind of pushing across here, across the plains, across the south, and big thunderstorm causers here. Again, 36 hours, 48 hours. So that's kind of what we're looking at here, guys, for the next couple days. So again, remember, start looking at these products. AOPA is a great one. And then also another one is aviationweather.gov. Aviationweather.gov is going to be another one for us to look at. So now what we're going to do is we're going to look at some Metars. If you do a search on the www, for instance, if you just Google aviation weather and you click on the aviation weather, the aviation weather link, it'll take you to a page, and underneath where it'll say aviationweather.gov, blah, 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 there will be another little subheading below that will say ADDS Metars. If you click that, it'll take you right to here. And what these are going to be Metars. So now let me show you how we kind of dial these in. So what I have done here is that I have added, and I'll take this out here right now. So if I get rid of this, if you add the ICAO identifiers, so I'm going to add KASE, which is Aspen, KASE, and leave a space. Then let's look at Eagle, KEGE, space. Let's look at Denver, KDEN. Let's look at New Orleans, KMSY. Let's look at Honolulu, PHNL, okay? And if I do that and I click Update, here we go. These are going to be our updates. Now I'm going to try to get this where I can move this around a little bit and center this slightly. So we're going to take a look at these right now, and we are going to decipher what these are, okay? So I'm going to walk you through the first few, and then we're going to talk about this, and we're going to give you some time here in class to kind of work a few of these, okay? So just be ready to pull some of these up on your trusty computer devices. I'm going to sip again here, guys. I'm still working on some throat stuff here today. Oh, tasty. Okay, so if we look here at KASE, let me see if I can use my little magic pen here. That'd be useful. Here we go, and hopefully this doesn't make it too small here for us to look at. I don't think it will. I think we can still see all of this okay. So here we are. This is the airport, KASE, the ICAO identifier. And remember here what we do here with this next part. 31, that's the day of the month, okay? And then the time that this was issued was 1353 Zulu. So if we take that out, and if we know that Aspen is 7 hours behind Greenwich Mean Time, what you do is you take 13 minus 7, and that gives you 6, right? So at 6:53 a.m. local time, that is when this Metar was published. You guys kind of see how that works? So that's how we do that. Remember, we work in a 24-hour clock with all things aviation. So there we go. I'll get that off there for you. So just remember, this is the date. This is the time in Zulu. Remember, what is the first thing they give us? Wind. Look at that. I don't see a lot of wind. When you see zeros, that kind of tells you the wind is calm, okay? Next, what do we get? Visibility, 10 statute miles. Looks pretty good, right? Then we get sky conditions. In this case, we have an overcast layer at 8,500 feet, okay? There's an overcast layer here at 8,500 feet. Then we have the temperature and dew point. Temperature, 0 degrees Celsius, and the dew point is minus 9 degrees Celsius. Altimeter, 30.01. Remarks. AO2, remember, is a precipitation discriminator, which is on the field, so it can tell the difference between snow and sleet and rain and mist and all that stuff. Sea level pressure, remember, we take the 10 and that's kind of assumed, and we do it like that. So here we have 1013.6, which again kind of checks here with a slightly higher than standard pressure. Standard pressure, 29.92. This is going to show a sea level pressure of 1013.6. Okay, kind of see how that works. Then we also wind up with the temperature here in a far more accurate piece. So here it's telling us that our temperature is 0. And I mean really 0, okay? So that's kind of what the temperature piece does in these first 4 digits. Then the last 4 digits we look at for the dew point. Now you'll notice that there is a 1 right here. Remember that the 1 indicates that this is going to be a negative number. So when you see the 1 there in front there of the first 4 digits, that's telling us it's a negative number. In this case, it is a negative 8.9. Round that up, and what do we get? We get 9, okay? So that's a METAR. And again, remember the purpose of these METARs. The purpose of these METARs is for pilots to get an idea of exactly what is happening at a particular given moment in time. And what is that moment in time? That moment in time is 13:53 Zulu, or 6:53 a.m. local time. Good so far? All right, let's try another one. Let's take a look over the hill at Eagle, K-E-G-E. Now you'll notice this one is on the 31st, but this report came at 13:56 Zulu. So these reports come here at 4 minutes until the hour versus 7 minutes until the hour here in Aspen. Something worth noting. What's the first thing they give us? Wind. Wind 050 at 4. Okay, that's kind of how this works. The first 3 digits over here tell the direction, and then the next digits will tell us the velocity. So in this case, the winds are 050 at 4. If we think again about kind of where we are with the compass rose, I want to just share this with you again. Just remember what the compass rose is sort of all about here. So up here at the top, you've got standby. Well, I don't know why that just did that. Interesting. Hang on here. Hang on. Okay, let's open that up. I don't know if I hit something weird or what. So we know that north is up here, 360 or 0. We know that south is down here at 180. We know that east is over here at 090. And we know that west is over here at 270. If you're standing right here in the center of this compass rose and you're looking at a particular number, this is telling you here that is the direction that the winds are coming from. So you can use this as kind of a heading type of a thing. If you're on a heading of 090, you're going east. If you're on a heading of 180, you're flying west because you're staring here at that number, right? So the wind is kind of the same way, because here, if you have a wind of, let's say, 050, you know that that wind is coming from this general direction. This general direction over here, of course, is going to be northeast. So the winds in Eagle out of the northeast, 050, at 4. Good so far? All right, let's take another little peek here at our magic screen. The next thing they give you is your visibility, 10 statute miles visibility, looking good. Clouds few at 7,500 feet. Is few a ceiling? Hey, oh, well, hello. I think that she said, I think she thought I said, hey Siri, but that's not what I said. I said, what is a ceiling? Okay, so not sure why she was talking to me there, but anyway. So with this, is few a ceiling? No. Is scattered a ceiling? No. Is broken a ceiling? Yes. Is overcast a ceiling? You betcha. So, remember what we saw there in the book. So here, clouds few at 7,500 feet. There's an overcast layer at 11,000 feet. Okay, overcast layer at 11,000 feet. Temperature here is -2 degrees. Dew point is -8. Altimeter 30.01. Remarks. There's a precipitation discriminator there as well. I'm not going to keep saying AO2 is a precipitation discriminator because it's still the same thing, so just remember that. Sea level pressure 1010.3, and then the temperature here, remember that both of these numbers are going to be negative. So they'll both start with a 1 here in that position. The temperature is -4.4, that's rounded to 4 degrees. And then I kind of cut off the other thing here. I don't know, how do I get that? There we go. So you can see this. And so you can see here that in this position, temperature is -4.4 degrees. We see a 1 here on the last 4 digits. And so that's going to tell us that our dew point here is -6.7 degrees. Now, those are relatively close together, so that would probably explain why we have got the cloud layers that we have here kind of above Eagle. That would be sort of my thought there. So we're going to put that back there, and I'm going to go back here. All right, so now let's look at the next one, which is Denver. All right, so here we go. We're going to look at Denver. KDEN, remember, this was on the 31st at 1353 Zulu, so it was taken at the same time Aspen. What are our winds? Can you see it? Winds, 100, so they're out of the east, basically. So remember, 090 is east, 100 is going to be the next 10-degree differential clockwise to that. At 7 knots, visibility, 10 statute miles, clouds few at 6,000 feet, scattered at 12,000 feet, broken ceiling layer at 22,000 feet. Temperature at that time, -4 degrees Celsius, dew point -7 degrees Celsius, altimeter 2988, which is just slightly less than standard, okay? So in this case, you're going to have a sea level pressure here of 1010.3. Temperature -4.4. You know what I think I did? I think I was looking at Denver's temperature on the example above. I apologize, guys, if you were looking at that and thinking, what the heck is that big bald man doing? Yeah, I was kind of looking at this temperature as opposed to this temperature and this, so I kind of got off on my lines there. So I do apologize. This is Denver, okay? That's Denver. That's the one we're looking at. So the sea level pressure there, 1010.3. Okay, remember how we do that. Remember, the 10 is kind of given unless it begins with a 9. If it begins with a 9, then we know it is not a 4-digit number. It's going to be a 3-digit number. And so this is going to be 1010.3. And again, remember the reason that we do this. 29.92 inches of mercury is equal to 1013.2 millibars or hectopascals. Okay, and then we can see our temperature and dew point, which I just showed you on the example before. Cleverly enough. You know how I like to stay ahead of the game. Let's take a look at Louisiana. Let's take a look here now at what's happening here at Louis Armstrong Airport here in New Orleans. So here we go. The date is the 31st. Time is 13:53 Zulu. Now here, because we're in the central time zone, we're 6 hours behind this, but it's still, we're still, as you look at this from where you're looking at, it's still that 7-hour differential thing, but here it's going to be 6. So with this, it was 7:53 local time, okay, as opposed to 7 hours back. We're in the central time zone, which right now we're 6, okay? So winds, 090 at 5. Where are the winds out of? They are from the east, okay? Visibility, 10 statute miles. Clouds, few at 25,000 feet. Temperature is a plus 8 degrees Celsius and a plus 4 degrees on the dew point. Altimeter, 30.30. And here, so that's a little bit higher than standard. This sea level pressure is going to equate to 1026.2, and then the temperature is 7.8 degrees Celsius and the dew point is 4.4 degrees Celsius. Go us. So that's kind of what's happening here in Louisiana. And if you remember sort of what we looked at before in the prognostication thing, when we looked at this, then we could kind of see that we might expect that kind of weather here, at least for now, this morning, before things kind of change for us later on in the day. Now, let's go to PHNL, Honolulu. Well, now wait a minute, Mr. R. You said that the U.S. cities, the airports begin with the letter K, with the ICAO identifier. That is correct. In the lower 48. That's what I said, because any of these other airports that are associated with the Pacific Ocean, they're going to begin with a P. Okay, so that's why the Hawaiian Islands, all of theirs begin with the letter P. Okay, so let's take a look here. PHNL, this is Honolulu. Woohoo! I can't remember how far behind Honolulu is to us right now, so I'm not even going to hazard a guess. But just know that it was at 13:53 Zulu. Okay, now in this case, we look at the winds. Winds are 180 at 8. That means they are from the south. 180 at 8 knots. Visibility 10 statute miles. There's a scattered layer of clouds at 2,000 feet. Okay, whoops, I wanted this one. Scattered layer of clouds at 2,000 feet. Another scattered layer at 4,300 feet. Are these ceilings? Not yet. Then we have a broken layer at 15,000 feet. Ceiling? You betcha. Temperature, 25 degrees Celsius. I hope, yes. And the dew point is 20 Celsius. Altimeter, 29.80, slightly lower than standard. So that means that the sea level pressure there is 1009.0, so slightly less than standard. And then we see the temperature over here. And then you'll notice a $sign at the end of this one. And the reason that you see the $sign over there is because it's expensive to go to Hawaii. That's not why that's there. There is a guide that I am going to share with you once I find it, that shows you kind of what some of these other rarely used METAR symbols are with this thing. So I will attempt to find those for you. Now then, this again, as you're looking at this is aviationweather.gov/METAR, okay? This is where you can go to not just find the current METARs for these airports, but it is a place to go to practice your METARs. And let me show you another little thing. If you look here at the top, you can see that you've got a couple of different types of formats that you can choose for this data. In this case, we're going to use the raw data. This is what they call it, because this is what the FAA is going to test you on. There's also a decoded plan for this. Well, that's just not sporting if you're an aviator. You know, you've got to learn the secret handshake, right? So when we look at these, this is a way that you can test yourself on these Metars. Then you can click decoded and look what happens. When you click the decoded part of this, look at this. Now you can see everything here in a decoded fashion. So when we do this, let me show you how to use this handy dandy little tool. Okay, so here we are. So remember, KASE, Aspen, Pitkin County, USA. Go us. America. Then it shows also the date, the 31st, okay, and it gives the time here. Now you'll notice now that there has been a new Metar that has been issued, because this one says 1453 Zulu. Okay, so this has changed since I pulled this up for the demonstration. Now it's showing here that the winds are 170 at 3. So the winds are going to be roughly from the south at 17 at 3 knots, okay, or 1.5 meters per second. Lovely. Visibility, 10 statute miles. Sky conditions. There's a broken layer now at 11,000 feet. Okay, that tells us that there is a ceiling at 11,000 feet. Then this gives us the temperature and dew point, -2 degrees Celsius, -7 degrees Celsius on the dew point, altimeter 30.00, and that gives us a sea level pressure of 1014.1. Here's the temperature breakout here. Remember that the ones are going to be negative numbers. And I don't recall what this piece of information back here means. Sometimes there's stuff that goes on in the back of these things that I just don't know. But that's the way you can do it. So let me show you one more time how we make this happen. aviationweather.gov/Metar. That'll bring you to the Metar page. You can plug in the airports. Remember that you put spaces between the 4-letter identifiers to give you a run of what airports you can pull the weather from. Okay, so with this, you can pull the raw data like we see here, and you'll notice that these have all been updated. And you can also see that you can get the decoded ones here also. Okay? Now, when you look at this, also notice this. We're going to get to this in I think the next video, I think. Include TAF, the Terminal Aerodrome Forecast. I want you to remember this because we're going to come back and use this tool to begin decoding the terminal aerodrome forecasts. Okay, so just remember we're going to use this also. All right, so this is where we look here to find our Metar information. aviationweather.gov/Metar. All right, so now I want to go back one screen, back another screen, let's go back again, and one more. Okay. This is what happens when you go right to aviationweather.gov/Metar. It takes you to these Metars. So what you do is you type in right here the codes for the airports that you want. All right, this is where you do it. Here is what I want you to do. I want you to independently, I want you to pull up the Metars for the following. This is going to be your practice here. Okay? Metars for the following. Come on, baby. Why isn't this working? Why isn't my pen working? Oh, there, no? I don't know. Do I have the wrong, what happened here? I don't know, my screens just went wonky. Don't know what happened here. Close this out. Let me try this again. Isn't this exciting? Welcome to live TV. So let's open this up again. Let's look at this. Let's try this one more time. I'm not sure what's happening. I don't know why my pen is not working. Well, that's just not right. Huh, I don't know. Let me try the other screen here. Stand by. Okay, I am going to go to this one. Hang on here, guys. Just remember that this worked in rehearsal. Was I on this one? Oh boy. Hang on here. Wow. Blank document, blah, 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 pages. 5, create document. All right, there's that. Let's go here. I'm going to try this. He's talking to himself again. Okay, so here are the airports that I want you to run the Metars on. These are the ones that I want you to practice on. Well, no, I don't want that. I want this. KASE. What is that one? Yes, Aspen. This one, I'm not going to tell you what they are now. This one. This one. That one. And by the way, I said yesterday that I thought MCO was Orlando. Was Kansas City. Turns out I was wrong. MCI is Kansas City, ORD is Chicago, duh, and MCO is Orlando. Speaking of Chicago, there's that one. Let's pick something else. I think I have that one right. Hang on here. Let's look at that. I want you guys to write these down. Okay. I want you to check these out. Hang on here. I'm checking something else here. I don't know why. Wow. I'm not sure why stuff is happening funky today. Okay. There's that one. And let's go with and I want this one. I think that's right. Let me double check that one. Okay. All right. I want you to pull up those nine airports, and I want you to do the I want you to do the Metars on these 9, and I want you to decipher these yourself. Use only the raw data when you pull these up, okay? Try to decipher them just using the raw data, okay? Then, after you think you've got it, then I want you to pull up, I want you to pull up the decoded data, okay? And then check your work against what's been decoded for you, all right? So this is what I want you to do. And I want you to pull these up and to do these. Can you do these right now? You should be able to. I mean, if you're watching me live, you should have some form of an internet connection, I would suspect. So let's pull these up. And I want you to spend the next few minutes on this thing. And I want you to practice some of these, okay? Then we're going to go over them here in the next 15 minutes. So in 15 minutes, we're going to look at these and we'll pull them up and we'll walk through them together, okay? So I want you to pause the video right now and look at these here over the next 15 minutes. Got it? Okay, pause the video. All right. All right, now then, let's go back and let's take a look and let's see what we have done here with these Metars. So, here we are. We've already kind of done KASE. So, with Aspen, here we are. The date is the 31st. The time is 14:53 Zulu. Winds 170 at 3, meaning they're roughly from the south at 3 knots, 10 statute miles visibility. Our ceiling layer is going to be broken at 11,000 feet. Remember, this is AGL, by the way. Temperature minus 2 degrees Celsius, dew point minus 7 degrees Celsius, altimeter 30.00, sea level pressure 1014.1, and then this shows the temperature here, minus 1.7 and minus 7.2. Okay, Eagle, here we are. It's on the 31st. And 1456 Zulu, winds 080 at 6, so that's roughly from the east at 6 knots, 10 statute miles visibility, and skies clear, okay? So then we have the temperature of 0 degrees Celsius, minus 7 on the dew point, altimeter 30.01, sea level pressure 1018.2, and then it gives the temperature and then a number back here that I just don't know what that is. KABQ, where is that? Albuquerque, New Mexico. New Mexico, not much different than the old one. So, 31st there, 1452, and I kid to my friends in New Mexico. So, 1452 Zulu, winds 150 at 3, that's roughly out of the southeast at 3 knots. Visibility 10 statute miles, clouds few at 22,000 feet AGL, another few layer there at 30,000 feet AGL. Temperature is going to be 1 degree Celsius, dew point minus 8 degrees Celsius, altimeter 30.13, sea level pressure, blah, blah, blah. There's the temperature and all that stuff. LAX, Los Angeles, California, City of Angels, I guess. So 31, it's on the 31st here today, 1453 Zulu. And this is kind of an interesting one here. I don't know, I've never seen this particular symbol. And guys, I got to tell you something. It's not uncommon. You see some stuff on here that's kind of crazy. So, the old duck on the wall tells me that we're kind of done with that, so we're just going to kind of scoot that on into the next video, which we are just going to continue. So here we are, COR. I want to say this is a corrected METAR on here. So it's showing winds 090 at 7, so they're out of the east at 7 knots. Visibility 10 statute miles. Clouds few at 1,500, few at 9,000, scattered at 14,000. Notice that we don't have a ceiling there yet. 15 degrees Celsius, which is approximately 60 degrees Fahrenheit. Minus 1 degree, so there's a big dew point spread there. Altimeter 29.98. How about that? And then we have sea level pressure 1015.2, and then the temperature here as well. PHOG, Maui. I believe that's Maui. And you can look at that there as well. 31st, 1454 Zulu. This is showing that it was done by an automated system. Winds 210 at 15. 210 is roughly out of the southwest at 15 knots. So kind of a brisk little wind out of the southeast. 9 statute miles visibility, skies clear. Temperature 23, dew point 20. Altimeter 29.80. And then it goes through here, 1009.5 is the sea level pressure. And then this. What is this? Thunderstorms. Thunderstorms, thunderstorms north. I'll have to look at the decode on that. Thunderstorms kind of to the north. Thunderstorms north observed. Not sure. We'll have to look at the decoded portion of this here, just to look at that. MCO. And so I think this is Orlando. I think, right? Mickey and Company. 31st, 1453 Zulu, winds 030 at 13 knots. So that's going to be kind of from the north-northeast. 10 statute miles visibility, skies cleared. 14 is the Celsius temperature. 6 is going to be the Celsius dew point. Altimeter 30.32. Remark sea level pressure. Here's our temperature here again. Great. Here we go. Chicago on the 31st, 1451, winds 210 at 14, gusting to 25 knots. So this is the first example of a gust. So winds 210, roughly out of the southwest at 14, with gusts to 25. Why would a pilot want to know about gusty conditions? Well, do you think that might have a kind of a factor here that the pilot may have to deal with whenever they land that airplane? Yeah. Visibility, 10 statute miles, clouds few at 16,000, broken at 25,000. Temperatures 2 degrees Celsius, dew point minus 6 degrees Celsius, altimeter 29.71, all of that, okay, there's that. Seattle, KSEA, Here we go, winds out of the south at 10 knots, 10 statute miles, visibility broken at 2,400. So we have a ceiling at 2,400 feet AGL, overcast at 10,000 feet AGL. And that I think kind of corresponds with some of the weather that we saw moving into that area. Temperature is 4 degrees Celsius, dew point 2 degrees Celsius, altimeter 3021. We go through there and just temperature, there it is. Okay. Now, Lahui on the island of Kauai. Automated. Winds out of the southwest at 4. 10 statute miles visibility. Light rain showers. A minus indicates light, a plus indicates heavy. Light rain is kind of reported there in that area or has been happening there. Scattered clouds at 5,000 feet, broken clouds at 6,000 feet, so there's our ceiling at 6,000 feet. They're overcast at 7,500, so we're looking at roughly 3 different layers there that this airport is reporting. The temperature is 21 degrees C, dew point is going to be 18. And again, I think some of the visibility issues there we can see with that 3-degree dew point spread, altimeter 29.78. And then we have the remarks here with this as well. Rain began at 48 minutes after the top of the hour. Rain began at 48 minutes after the hour. Then it gives the sea level pressure. This tells us, I want to say that this is kind of a precipitation calculator here, that it kind of tells you how much precipitation that they have received in the past hour, and I don't see anything there, and I'm not sure what that 6,000 means. Let's take a look here and let's figure out what these things are with the update. So let's go decode and let's go with the updates. So the ones I want to look at are kind of the non-standard ones here. I want to just see where we are. So I think all of those others were pretty straightforward. And I'm not seeing this one here at Kahului there in Maui. I do know that the automated piece here shows up here with no human augmentation. Oh, good heavens, let's not have that. Any human augmentation. And it's not showing here what that TSNO stands for, so I'm not real sure. Maybe the next one will. And I'm looking, I don't seeing, not there. Yeah, the only thing that I'm not seeing there is what that TSNO stands for. Not real sure. Okay. All right, so we're looking at those. So guys, that's how I want you to do it. So you will probably expect some form of a quiz coming near you, perhaps on Friday, about Metars, okay? And here's why I'm spending so much time on this. We talk about the things that you need to know to do well on the test. That's great. But these, again, are things that you need to know to operate an aircraft safely and to make sure that you're not flying into an area of weather that you're not ready for, that you're unexpecting, or perhaps you can't handle. And that's kind of what we're trying to do here. And this is why we do this work on the Metars. So, I want you to do some work, and here's what I want you to do. What are your 10 favorite cities in the United States? What are your 10 favorite cities? I want you to write the names of the cities down. Then I want you to look up the ICAO identifiers for those 10 cities. I want you to go back into the aviationweather.gov/METAR tool, and I want you to enter those ICAO identifiers, the 4-letter identifiers, for those 10 cities. Practice the METARs. Find out where they are. And don't make all the cities in like one little cluster of the country. Spread them out. This also gives you a pretty good view of what's happening around the country here also. So spread those cities out, look at them, try to do the METARs first without looking at the decoded portion of it, then look at the decoded and see how you did. Because there will be a quiz coming to you Friday, and it's going to be on decoding METARs. Okay? So that's what we're going to do. The next session that we do is going to be on, well, I can't say that because I need to look in the book to see what's after METARs. But I know that right now I've gone over on my time here for this thing. So this video is intended for the entirety of the Wednesday class. So just keep that in mind. If you have time right now and you still have time in the class between doing these METARs, I want you to pick those 10 cities and I want you to practice, okay? Because we are going to have a METAR quiz on Friday, okay? So, guys, there you go. Have an awesome Wednesday, and I will talk to you guys later. I will see you soon. Hang on, let me see if I can do this. Okay, stop the event.